Hello everyone. I am Professor Sanjay Agarwal, Pro Vice Chancellor of Chhattisgarh Swami Vivekanand Technical University, Bhilai. And I am also the course coordinator of this particular course, that is Industrial Automation and Drives. I welcome you all to the second lecture of this course, which is focusing on Introduction to Basic Electrical Principles. Dear learner, in this lecture, we will talk about the basics of the electricity, like we will discuss what is the charge, what is a voltage, what is a current. So, as you know, the tiny particles that make electricity is called basically charge, and the force that move these particles can be defined as voltage, and how fast these particles flow can be termed as current. If we talk about the resistance, so what slows down the flow of these particles is called resistance. Dear learner, we will then learn about Ohm's law, which connects voltage, current and resistance. We will also discuss energy and power in the electrical circuit, like suppose we have to define the energy and power. So in the simple language you can say how much work the electricity can do can be termed as energy. So basically, you know, the energy is basically, it is a product of power and time. If you talk about the power, so you, in the simple language, you can define power as how quickly it does this work is called basically power. Lastly, we will learn about two types of electricity, like DC current, which is called direct current, and then alternating current, which is also called AC current. So in DC current, what happens? The electricity flows in one direction, or you can say the magnitude of voltage or current does not change with respect to the time. If we talk about the alternating current, here electricity changes direction back and forth, or you can say the magnitude of voltage and current changes with respect to the time, that can be defined as alternating current. In case of alternating current, if we want to define, like suppose voltage, so what will happen, and if you are drawing, if you are showing time on the horizontal axis and magnitude either voltage or current on the vertical axis, so what will happen, this voltage will go from 0 to maximum, then maximum to 0, then 0 to negative maximum, then negative maximum to 0. So this is the way the alternating current can be defined. So now let us start the first topic of this particular topic. So let us start the first topic, that is charge. So charge is a fundamental property of a matter that causes it to experience a force when placed in electric or magnetic field. It is the basis for the electric phenomena and interactions. It is an intrinsic property of the elementary particles like electrons and protons, and it determines how these particles interact with each other. The unit of electric charge is coulomb, which is denoted as capital C. So 1 coulomb is the large unit of charge, and it is approximately equal to the charge of 6.242 into 10 to the power 18 electrons. The charge of a single electron is approximately is equal to minus 1.6 into 10 to the power minus 19 coulombs, while proton carries a charge of 1.6 into 10 to the power minus 19 coulombs. Now we will discuss different type of charges. So it can be defined as positive charges, negative charges and neutral. So if we talk about the positive charges, so positive charges are carried by the protons. For example, a hydrogen nucleus, a single proton has a positive charge. If we talk about the negative charge, it is carried by the electrons, and for example, the electron in an atom carry are negative charges. If we talk about the neutral, when an object has an equal number of positive and negative charges, it is electrically neutral and exhibits no overall charge. Now we will discuss about the properties of the charges. So one property you can say attraction and repulsion. So like charges repel each other while opposite charges attract each other. This principle is the basis for many electrical and magnetic phenomena. If we talk about the another property like conservation of the charges, The total charge in an isolated system remains constant. Charge cannot be created or destroyed but can be transferred from one object to the another. If we talk about the another properties, that is a quantization, charges is quantized, meaning it comes in discrete unit. The smallest unit of charge is the charge of a single electron or proton. Now we will discuss the examples in everyday life. Like suppose first we discuss the static electricity. So you must have observed that when you rub a balloon on your hair, electrons are transferred from your hair to the balloon. Your hair becomes positive charge and the balloon becomes negative charge, causing them to attract. If we talk about the another example in everyday life, that is lightning. So during a thunderstorm, friction between particles in the clouds causes charge to separate, leading to a buildup of negative charge at the bottom of the cloud and the positive charge at the top. When the difference in charge becomes large enough, it can result in a sudden discharge known as lightning. If we talk about the batteries, so what is a batteries? A battery stores charge with a surplus of electron, which is basically you can say it is a negative charge at one terminal and deficit, that is a positive charge, at the other. This difference in charge creates a voltage that can drive current through a circuit when battery is connected. Now let us move on to the another crucial concept in the electricity, that is voltage. So understanding voltage is key to learn how electricity flows and power our devices. So now we first define the voltage. Voltage, also known as electric potential difference, is a measure of the potential energy per unit charge between 2 points in an electric circuit. It is measured in volt. Generally, it is denoted by the capital V. The word electric potential difference refers to the difference in electric potential energy per unit charge between 2 points in an electric field. Essentially, it describes how much potential energy is available to move charge from one point to another. Similarly, volt measures the amount of potential energy per unit charge. 1 volt is equivalent to 1 joule of energy per coulomb of charge. In the simplest term, voltage is like the push or force that moves electric charge through a circuit. Higher voltage means more potential energy available to move charge. Look at some everyday example of voltage. Like if we talk about the batteries, a typical AA battery has a voltage of around 1.5 volt. This voltage provides the energy needed to power device like remote controls. If you talk about the wall outlets, in homes, wall outlet typically provide 120 volt in the US or 230 volt in many other countries like India. This higher voltage allows larger appliances like refrigerator and washing machines to operate. If you talk about the lightning, lightning is a natural example of extremely high voltage discharge due to the buildup of charge in clouds. Now let us talk about another fundamental concept in electricity, that is current. So first we will define the current. What is a current? Current is the flow of electric charge per unit of time. Current describes how electric charge carriers such as electrons or ions move through a conductor like a wire. These charges move in response to an electric field created by a voltage. In simpler terms, current is like the flow or stream of electric charge moving through a circuit in response to a voltage. Current is basically measured in ampere. Amperes measure the rate of flow of electric charge. So you can say 1 ampere is equal to 1 coulomb of charge passing a point per second. Now we will discuss conventional current direction versus electron flow. It is very important to note that conventional current direction, historically current flows was thought to be from positive to negative terminal in a circuit. This is called the conventional current direction. If we talk about the electron flow, so in reality electron flow from negative to positive terminal due to their negative charge. So while conventional current direction is from positive to negative, and actual electron is flow from negative to positive. Now let us see some everyday example of current. You can take the example of like light bulbs. So when you switch on a light bulb, current flows through a filament causing it to glow and emit light. If we talk about the electronics, so in devices like a smartphone and the computers, current flows through the circuit to power components such as processor and the screens. If we talk about the household appliances, so in this current power appliances like refrigerator and washing machines, allowing them to function efficiently. Now if we talk about the type of the current, as we have already discussed in the beginning, like current can be defined as a direct current and the alternating current. If we talk about the direct current, so in case of DC current, current flows in one direction. It is typically provided by the batteries and the DC power supply. If we talk about the alternating current, current alternates direction periodically. It is the type of current used in most household and industrial electrical systems. Next, we are diving to another crucial concept in the electricity, that is called resistance. So now let us define the resistance. What is a resistance? Resistance is nothing, it is the opposition encountered by the electric current as it flows through a conductor. Opposition to current flow means resistance refers to how much a material resists the flow of electric current. Ohms measures the amount of resistance in a circuit. 1 ohm is the amount of resistance that allows 1 ampere of current to flow. 1 volt of voltage is applied. In simpler term, resistance is like a barrier that slows down the flow of electric current in a circuit. Let us look at some example of resistance in action, like light bulb. The filament in incandescent light bulb has high resistance, causing it to heat up and produce light. If we talk about the heating element, electric stoves and toaster use high resistance wires to generate heat. Another example if we talk, that is a fuses. Fuses in electrical circuit are designed to have a specific resistance. If current exceeds some safe limits, the fuse heats up and breaks the circuit to protect device from the damage. Now let us explore the Ohm's law. Ohm's law is essential for understanding how voltage, current and resistance are related in a circuit. So Ohm's law states that the current flowing through a conductor between 2 points is directly proportional to the voltage across the 2 points and inversely proportional to the resistance in the conductor if physical conditions are kept constant like temperature and pressure. If we talk about the mathematically, so mathematically Ohm's law is expressed as V is equal to I into R, where V is what? V is a voltage, I is a current flowing through the circuit and R is the resistance. If we talk about this direct proportionality, so this means that if you increase the voltage across the conductor keeping the resistance constant, the current flowing through it will increase proportionality. If we talk about the inverse proportionality, if you increase the resistance of the conductor keeping voltage constant, the current flowing through it will decrease proportionality. Ohm's law helps us predict how changes in the voltage, current and resistance affect each other in a circuit. Now let us apply Ohm's law with an example. Suppose we have a circuit with a resistor of 10 ohms. If we apply a voltage of 12 volt across the resistor, Ohm's law tells us that current flowing through the resistor can be calculated as I is equal to V upon R, where V is what? V is a 12 volt and resistance is 10 ohm. So 12 divided by 10, it's come 1.2 ampere. Now we will discuss energy and powers in the electric circuit. So today we will discuss two crucial concepts in the electrical circuit like energy and power. These concepts help us understand how electrical systems do work and consume resources. Energy in electrical circuit is the capacity to do work. It is measured in joule. And if we talk about the power, power is the rate at which electrical energy is transferred or converted. It is measured in watt. In simple term, energy is the total work an electrical system can do, while power tells us how quickly it can do that particular work. The energy consumed by an electrical device can be calculated using this particular formula, that is E is equal to power multiplied by time, or you can say E is equal to P into T, where E is energy in the joule, P is the power in the watt and T is time in second. For example, if any device uses 100 watt of power for 2 hours, the energy consumed is equal to what? Is equal to 100 into 2 hour, or if you multiplied or you convert it into second, so it comes around 720,000 joule. And power is in electrical circuit is calculated by formula P equal to V into I, where P is power in watt, V is voltage in volt and I is current in ampere. So if you have a light bulb operating at 120 volt and drawing a current of 0.5 ampere, the power consumed is what? Just you have a formula, that is P is equal to V into I. Just now you have to put the value of this voltage and current. What is the value of voltage? The value of voltage is 120 voltage and current is 0.5 ampere. So if you multiply with this 120 into 0.5, so it comes 60, and the unit of this power is what? The unit of power is watt. So you can say this power is coming is equal to 60 watt. Now take the example like a batteries. So the capacity of battery is often given in milliampere hour like mAh or ampere hour. For instance, 2000 mAh battery can provide 2000 milliampere for 1 hour. This relates to the energy stored in the battery. If we talk about the electric vehicle, so the range of electric vehicle is determined by the energy stored in the batteries and it is measured in kilowatt hour. Generally it is denoted as kWh, where this K is small and capital W and H is small h. So if you talk about that you are consuming so much unit of electrical energy, like we say that in your house you are using 5 unit of electrical energy, that means you can write 1 unit electrical energy is equal to 1 kWh. Now we talk about the power. So example is a light bulb. So a 60 watt light bulb use electrical power at a rate of 60 joule per second. This means it consumes energy faster than a 40 watt bulb. If we talk about the appliances, so you can take an example of any appliances like 1500 watt hair dryer, which uses more power, therefore heats up faster than 1000 watt hair dryer. Now we have to understand the what is the energy management, safety and performance. So understanding energy power is crucial for energy management, safety and performance. So we talk about the energy management means designing circuit that efficiently use energy, reducing waste and operating cost. It comes under the energy management. If we talk about the safety, so safety ensuring device do not consume more power than they are designed to handle, preventing overheating and damage. If we talk about the performance, so optimizing the performance of device by balancing power consumption with energy efficiency. So to summarize, energy is the capacity to do work in a circuit and power is the rate at which that energy is used or converted. Both concepts are essential for understanding how electrical systems function and manage resources. So now let us talk about the direct current and alternating current. That has already been discussed. Now again we will focus about on the DC current and AC current. So DC is a type of electric current that flows in the constant direction with a steady voltage. It means electric charges, or you can say electrons, moves uniformly from positive terminal to the negative terminal. The voltage and current in DC circuit are constant over time, meaning they do not vary or fluctuate over the time. This steady flow is typically represented as a flat horizontal line on a graph over time. That means if you draw any quantity, whether it is a voltage or current, with respect to the time, that curve comes horizontally with respect to the time. Now we talk about the sources. The common source of DC are batteries, which provide a constant voltage output. Batteries are found in everything from small device like remote control to larger application like car and backup power supplies. Now another example we can understand like a solar panel. Solar panel means like a PV module, or you can say the solar cell or the PV array. So what solar panel does? They generate DC by converting sunlight directly into electricity through the photovoltaic effect. So what about the current or voltage that you are getting from the solar panel or the PV panel? It generates basically the DC power. Now we will discuss some applications like in electronic device. Most small electronics such as smartphone, laptop and tablet operate on the DC power. These devices have internal batteries that store and provide DC. If we talk about the electric vehicles, DC is used in electric vehicle to power the motor and other electronic system. EV battery store DC and supply it to the motor controller. If we talk about the LED lighting, LED operate on DC, so even though they might be connected to an AC supply, they internally convert it to a DC. If we talk about the portable chargers and the power banks, these devices store energy as DC and provide AC to charge other devices. Now we will discuss the advantage and disadvantage of DC. So first we will discuss what are the advantages of the DC. So first advantage is simplicity, means DC system are simpler and cheaper for low voltage application. If we talk about the another advantage, so you can say it is efficient for the short distances, like DC is efficient for short distance power transmission, making it ideal for the portable and small scale devices. If we talk about another advantage like you can say stable voltage. If we talk about the disadvantage of the DC, so the most uh, disadvantage of DC is transmission losses, means in case of DC it is less efficient for the long distance transmission because it cannot easily change the voltage level. That means suppose you take the example, this power is constant. So if you are transmitting the power by some ACSR conductor or negative conductor, that means you cannot step up the voltage. So that means current flowing through the conductor is more. If current flowing through the conductor is more, that means this I square R losses are the more. That means if losses are the more, that means whatever the power you are getting at the receiving end side, you will get the less power. That's why we say that transmission losses are more if you transmit power through the DC supply. Another disadvantage is complex conversion. What is the meaning of this complex conversion? Means converting DC to AC or changing voltage level in DC require complex and costly electronics. Now we will discuss about the alternating current. Alternating current is a type of electric current where the flow of electric charge periodically reverse direction. The voltage and the current level also vary with time typical in a sinusoidal waveform that is called alternating current. In AC, the electrons periodically switch direction, moving back and forth around the circuit. This oscillation allows AC to efficiently transmit power over long distance. The voltage and current vary over time, usually in a sine wave pattern, which means they rise to a peak value, drop to zero, reverse, and then repeat. Now we will understand what are the sources of this AC power. So first source is a power plant. Like AC is generated by the alternator in the power plant and it is transmitted through electrical grid to the homes and industries. Another source of AC power is generator. Portable and standby generator produce AC power for use in emergencies or the remote location. Another source you can say the inverter, device that convert DC into AC for use with the standard AC appliances. Understand what are the applications of this AC power. So if we talk about the household power, AC is used to power most household appliances including lights, refrigerator, air conditioner, televisions, etc. The standard household supply is typically 220 volt AC supply. If we talk about the industrial power, AC power industrial equipment and machinery due to its efficiency in transmitting over long distance and its ease of conversion to different voltages. If we talk about the power distribution, AC is used in the electrical grid because it can easily be transformed to higher or lower voltage level using transformers, making it suitable for long distance transmission. Now we have to understand what is the frequency and this phase concept. So what is the frequency? So AC is defined by its frequency measured in hertz, which indicates how many cycles per second the current reverses the direction. In India, the standard frequency is 50 hertz. Now we have to understand what is a phase. Generally we say the power is coming single phase or three phase. So what is a phase? AC can be single phase or three phase. Single phase AC is common in residential settings, while three phase AC is used in industrial and commercial setting for its efficiency in delivering large amount of power. If we talk about a single phase AC, it provides a single alternating voltage and is used for most household application. If we talk about three phase AC, it provides three alternating voltages, each out of phase with each other by 120 degree and is used in industrial and large scale power distribution for its ability to carry more power with greater efficiency. Now we have to understand what are the advantages and disadvantages of the AC power. So first advantage of AC power is efficient transmission. Like AC is ideal for transmitting electricity over long distance due to the ease of changing voltage level with transformer. Another advantage is cost effective, means generally most AC power is more cost effective for large scale power distribution and industrial application. The disadvantage of AC is complex circuit and less suitable for the electronics. So AC circuit can be more complex due to need to manage varying voltage and phases. If we talk about the disadvantage of this AC, it is less suitable for electronics, like many electronic devices require stable DC power, so they need internal converter when supplied with AC. So now let us compare AC and DC to understand their unique advantage and disadvantage better. So we have already discussed what are the advantage and disadvantage of AC and DC power. What is the difference between AC and DC? So if we talk about the direction of the flow, you can say it is a one direction DC current flows. In case of AC, periodically reverse direction. If we talk about the voltage and current behavior, so in case of DC it is a steady and constant, but in case of AC it varies sinusoidally over the time. If we talk about the transmission efficiency, so in case of DC it is less efficient for the long distance, and if we talk about the AC, so it is more efficient for the long distance. If we talk about the transmission efficiency, if we talk about the transformation, so in case of DC it requires complex electronic to change voltage level, but in case of AC it is easily transformed to different voltage level with the transformer. If we talk about the application, so low voltage and portable device electronics are required. In case of AC, it is used in the household power, industrial application, power grid. If we talk about the generation, what are the sources of the DC and AC? So sources of the DC are the battery and the solar cell, and in case of AC, the sources are the power plant and generators. So now let us sum up the second lecture. So in our second lecture on introduction to basic electrical principle, we have covered basic electrical quantities like what is a charge, what is a voltage, how you can define the current and resistance. Then we have also discussed about the Ohm's law, which relates the voltage, current and the resistance. Then we have discussed in the detail what is the difference between energy and power, and in the lastly we have discussed about in the what is the comparison of the DC and AC, what are the advantage and disadvantage of AC power and DC power. Dear learner, in the next section we will explore electrical component and the circuit, which are the fundamental for understanding how industrial automation system work. Thank you very much.